Okay, in this video, I just want to go over just rearranging equations and making certain things the subjects. So, what is a subject? Let's take this example: speed equals distance over time. The subject of a formula, it's the variable that's isolated on one side. So here, what's the subject? This one that starts with S, huh? It's the speed. Right, we're defining this equation, trying to find speed in terms of everything else. Speed equals distance over time. Think of a runner, right? A runner ran, let's say, 10 kilometers, and it took him an hour. What's his speed? 10 over 1 is 10. So his speed is 10 kilometers per hour. In an hour, he ran 10 kilometers. Pretty obvious. Let's say we know his speed is 10 kilometers an hour. And let's say we know the time is 2 hours. So what's the distance? What's D? Well, to find D, we know, let's just sub in our value. Speed is 10. So 10 equals distance over 2. Well, to find the distance, we want to make it the subject of the formula. We want to find what distance is in terms of everything else. So to make distance on its own, what's happening to distance? What's happening to distance? It's being divided by 2. So to get rid of it being divided by 2, we have to multiply multiply by 2. And whatever we do to one side, we have to do to the other. So distance equals 20. So he ran 20 kilometers to run. Let's do another example. Area equals pi r squared. This is the formula for the area of a circle, not an ellipsis. Come on. There you go. Let's say we have the radius. Let's say it's 4. Well, what's the area of the circle? Area equals 4 squared is 16 pi. Pretty simple, right? We find the area right away because the area is the subject. Yeah, that's why it's very easy. But what if the area, I have the radius, what if the area is 5? 5 equals, 5 equals pi r squared. If you want to find r, that's pretty tough, right? How can we figure it out? Again, we just want to make r the subject. So what's happening to r right now? There's a couple of things. It's being squared and it's being multiplied by pi. Let's get rid of the pi first. If it's being multiplied by pi, how can we get rid of the pi? We divide by pi. We divide by pi, right? So r squared equals 5 over pi. Now what's happening to r? It's being squared. How can we get rid of the square? We take the square root. Square rooting both sides. R equals square root of 5 over pi. Now we can find r pretty easily, right? Let's get rid of the 5 because the 5 is the area. So if we have the area, it's pretty simple to find r, which is sub in a, and we put it in the calculator for r or whatever. So what I'm trying to get at is, why do we rearrange formulas? Why might we need to do this? I think, in my head, there's applications in math, engineering, physics, whatever, to find values in terms of other values. Okay? So how do we do this? How do we make something the subject of a formula? Well, off these examples, there's a few steps. I guess the first one, just to be concrete, we identify. You have to identify the variable that we want to make the subject. So a equals pi r squared. Come on, a equals pi r squared. If we want to make a the subject, well, we don't have to do anything, right? A is already the subject. If we want to make r the subject, well, we know it's r. So it's a pretty mundane step, just identifying what thing we need to make the subject. What's step 2? I guess step 2 is, applying operations, right? We get rid of the things that are happening to the variable. And in doing this, we also have to keep it balanced, right? Whatever we do to one side, we have to do to the other. And actually, that's pretty much it. It's only 2 steps. You just keep reiterating on step 2, really. Okay. Maybe it doesn't make too much sense, but if we do the examples, it'll make more sense. Now in that second step, we do operations, right? We have to identify what's happening to r and sort of apply the inverse of the operation. So if something is being added, let's say we identified the variable we want to make the subject to be r. If something's being added to r, what's the opposite of addition? It's subtraction. So let's write these down. Inverse operations. The first one, if it's plus, well, what's the opposite of plus? It's minus, right? There's supposed to be 2 arrows, right? So from plus to minus, from minus to plus. right? If something's being multiplied, what's the opposite of multiplication? It's division, right? What else? Oh, we've got squaring. If something is being squared, well, what's the opposite? We take the square root. Or more accurately, if something is taken to the nth power, well, the opposite is taking the nth root. Okay. And there's a couple more. They're a bit harder to explain. I'll go over them in a bit. One is logs, and the other is I guess like factoring, right? Factoring like 2. So let's do a few examples. Area of a triangle equals half its breadth times its height. Let's say we have the area and the breadth, and we want to make h the subject. We want to make h the subject. Well, what's happening to h? It's being multiplied by half, and it's also being multiplied by b. We could get rid of half b in one step, but I want to take it step by step. So let's take it easy. How do you get rid of the half first? You can think of h as being multiplied by half or divided by 2. Let's go with divided by 2. H is being divided by 2. How can we get rid of that? We multiply by 2. Multiply both sides by 2. 2a equals bh. Now h is being multiplied by b. What's the opposite of multiplication? It's division. So we divide both sides by b. H equals 2a over b. So given the breadth and area of a triangle, we can use this formula to find its height. Okay, about another one. Let's do how do I move? Okay, we'll do it here. Let's say P equals 2L plus 2W over H, and we want to make H the subject. So what's happening to H right now? It's hard to say what's happening to it. It's the divisor in this case. It's not being divided, it's actually the divisor. But we know it has to do with division, and what's the opposite of division? It's multiplication. So what we want to do, we want to multiply both sides by h. Multiply this side by h and multiply that side by h. These h's will of course cancel out, and we're left with ph equals 2l plus 2w. Now what's happening to h is being multiplied by p. Opposite of multiplication is division. Divide both sides by p. H equals 2l plus 2w over p. Okay, let's do a similar one. F, I think this one's the force. This is actually a popular formula. Force equals big G, I think this is the gravity of Earth, times mass 1, mass 2, over r squared, which is just the radius. Anyways, we're going to make r the subject. So just like before, r is being divided right now, right? Or it's not being divided, it's being divided. I don't know what's the word. I know it has to do with division. What's the opposite of division? It's multiplication. Let's multiply both sides by r squared. R squared here and r squared there. F r squared equals g m1 m2. Now what's happening to r? It's being multiplied by f. Let's get rid of the f with the opposite of multiplication, which is division. R squared is cancelled out. Equals g m1 m2 over f. And finally, what's happening to r? It's being squared, so we have to take its square root. So taking the square root of both sides, this cancels out, and you've got the square root on the right hand side. We made r the subject successfully. Okay, and one more. I equals what? I equals v minus I r over capital R. Okay, and we want to make I the subject. This one's a bit harder, right? Because we've got I on this side and I on that side. So what should we do? I think the best thing we can do to get started, we want to make all the I's on one side and whatever else we can on the other side. So first, let's it's always good to get rid of fractions. We got the fraction here with r, and it's affecting I, right? How do you get rid of the r? We multiply both sides by r. It's being divided by r. To get rid of the r is the opposite of division is multiplication. So multiplying both sides by r, we get ri equals v minus I r. And I said I want to make all the i's on one side. let's bring this I to this side. So how do we make it to the other side? We're going to add IR to both sides. So RI plus IR equals V minus IR plus IR, which is just V. So we've got all the I's on one side. That's good. And hold on. Whoops. This is supposed to be a tiny r. Whoops. Remember? Right, from the original formula, it's a tiny r. My bad. I should have used a different variable. Okay, now all the i's are on one side. We want to make the I on its own. We've got two things with I in them. But what we can do is take out like terms. So remember, the opposite of brackets is factoring, and the opposite of factoring is brackets. Although I don't like to think of it like that way. We just want to make I on its own. R, I, and IR, or capital RI and I normal R. We can take out the I. It's a like term between them. I equals R plus R equals V. Right? And if we expand these brackets, we'll get back to this. Anyhow, I is being multiplied by R plus R. How can we make I on its own? It's being multiplied by these two. What do you want to do? We want to divide by that thing. So we divide both sides by R plus R. Right? These two, of course, cancel out. I is on its own, and I equals V over R plus R. Maybe it's a bit confusing, but nothing comes easy without practice. Okay, let's do one more. Now think about these questions. Almost always you can get the answer by following those inverse operations. So if you have a plus, you take the minus. You have times, you take the division. All that stuff. How about this one? X squared, or actually let's take ax squared plus bx plus c. And let's say this equals 0. And I want to make x the subject. Right? This one's pretty hard. I'll walk you through it. Of course, you can't do it with our normal inverse operations. You have to have a very key little sort of trick. It's called completing the square. I'll show you how it works in a second. For now, I want to make x squared on its own. It's being multiplied by a, right? We want to get rid of the a. It's being multiplied by a, we want to divide by a. So dividing everything by a, x squared plus b over a x plus c over a. That equals 0, because 0 divided by a is, of course, 0. And let's take this ca, this constant, to the other side. We want to leave the x's on their own. So you're left with equals negative c over a. We subtracted ca from both sides. Okay, now there's a certain thing I want to get. This term is half of b over a squared. What's half of ba squared? What's 1 over 2, or it's b over 2a. What the heck? Okay, it's b over 2a squared, which equals b squared over 4a squared. Okay, we have this term. I want to add this term to both sides. And why can I do that? Whatever I do to one side, I can do to the other side. So I just want to do that, like from my head. So it becomes x squared plus b over a x. And I want to add plus b squared over 4a squared. And yeah, whatever you do to one side, you have to do the other side. B squared over 4a squared minus c over a. And let's combine the right fraction, just because I want to. How can we combine them? Well, we have to make the denominator the same. What's this missing that this has? A 2a. Oh no, 4a. It's missing 4a. So this equals b squared minus 4ac over 4a squared. Okay. So now what we can do, I'm looking at the left-hand side. What we can do with the left-hand side is this. The left-hand side is actually equal to x plus b over 2a squared. So this whole thing actually equals that. That's my claim. How can I prove it? We can simply expand it. So how do you expand the square brackets? You take the first one squared, and you take the last one squared, and you take 2 times the first one and the second one. So plus 2 times x times b over 2a. The 2's cancel out, and you're left with x times b over 2a, which is what x squared maps to x squared. ba times x is right here, b over a times x, and b squared over 4a squared is right there. So they're actually equal. So we use a nice little trick to do that. So x plus, just counting what we did, x plus b over 2a all squared equals, so what's on the right hand side? B squared minus 4ac over 4a squared. So you're not expected to know this. This is called the quadratic formula. You actually just have to memorize it. But it's a nice little thing to know that you can prove it as long as you know these little annoying tricks. So how do we make x the subject now? X is already on one side. What's happening to x? It's being squared. What's the opposite of squaring? It's square rooting. So we take the root of both sides. X plus b over 2a equals, well, we take the square root of the top, b squared minus 4ac. And what's the square root of the bottom? What's the square root of 4a squared? Well, the square root of 4 is 2, and the square root of a is a. And what's the last thing we have to do? X. We subtract the b over 2a from both sides. X is being added by b over 2a. The opposite of addition is subtraction. X equals root b squared minus 4ac over 2a minus b over 2a. And look, it's the denominator is shared, so we can just combine the fractions. So we have now b squared minus 4ac, the square root of that, minus b. And you might often see, just to finish off, you often see for the quadratic formula you have this plus minus here. That's expected, right? Because a square root is a plus or minus in general. Take the square root of 4. The square root of 4 is 2, because 2 squared equals 4. But what about negative 2 squared? That also equals 4. There's always sort of 2 solutions. Okay, that's nice. That's a pretty hard example. You're not expected to know it, but you see we use all our little tricks to figure out the formula. All those inverse operations, save for that completing the square a little bit. But yeah, I'm just sort of showcasing something kind of neat. You're not expected to know this. Okay, so I'm nearly done. I'm going to give you a few examples. Let's do k equals mv squared over 2. I want you to make, actually I'll outline in the end. T equals 2 pi square root L over G. This is an L. A equals P 1 plus R power of T minus 1. V equals 4 over 3 pi R power of 3 on 2. And Y equals x plus a over x minus a, and 1 over a plus 1 over b equals 1 over c squared. Okay, we have a few questions, kind of tough. I want you to have a crack. For each equation I want you to make, so this one v the subject, this one L, this one T, this one obviously R, this one X, and this one C. A few tough questions, but using what we've learned today, you can definitely crack them. I guess the final thing worth covering is the log stuff. Now, I don't see log stuff come up, so I'm just gonna, you don't have to know it too much. Take this equation, a to the power of x equals y. Okay, what is this? If we look at it in terms of x, what is this equation asking in layman terms? We're asking a to what power gives y? A to what power gives y? Let's give some values for a and y. Let's take 2 to the x equals y. 4. We're asking 2 to what power gives 4? If you're kind of smart, you'd know x equals 2, since 2 squared equals 4. So, pretty simple. how can we make x the subject? We're asking x to what power, 2 to what power gives 4, or a to what power gives y. How can we make x the subject? Well, what we do is we take the log of both sides, and log by definition, that's what it means. It's like this thing to what power gives the other thing. Anyways, let's take the log of both sides. Remember, what you do to one side, you have to do to the other. So log of 2 to the x equals log of 4. Now the thing about logs is that when you have something like this, 2 to the power of x, you can actually take the x to the outside. It's the way we define it. So x log 2 equals log 4. Okay, now how can we make x the subject? Well, x is being multiplied by log 2. What's the opposite of multiplication? It's division. So x equals log 4 over log 2. Okay, nice. So it's not too much. It's not too tough. I guess the one thing I've got to show you is this example. You can't do it without knowing this. Okay, we're gonna make t the subject. How can we do that? Well, for now, t is part of this thing, this brackets, which is being multiplied by p. So for now, I just want to get rid of the p. That'll make things simpler for us. This whole thing is being multiplied by p. It's being multiplied by p when I divide by p. So we divide both sides by p. A over p equals 1 plus r to the t. And just like we did before, you want to take the log of both sides. That's how we get rid of the you see, I guess maybe you might get confused by the exponential and this t. So if we have x squared equals 4, well, if we're looking for x and to get rid of the power, we want to take the square root, right? But if it's the other way around, if the thing we're looking for is the power itself, that's when you start doing logs. So in this case, we're not looking for r, we're looking for t. T is the power. If we're dealing with the power, we want to take the log. So let's take the log of both sides. Log a over p equals log of 1 plus r to the power of t, right? And what did I say? If you're taking the power, you can take out the t. So the t can go on the outside. So t times log 1 plus r equals log of a over p. And t is being multiplied by something now. How do we go to multiplication? It's division. So t equals log a over p over log of 1 plus r. Okay, not too hard. A bit advanced, but you know, it's all about the rules and the inverse operations. And that's it for the lesson. Here's a few pretty tough questions. You don't really need to know this one too bad because it's logs and all that. But yeah, have a go. I think I'll make like a PDF of a bunch of questions, or I'll just look in the textbook. I think there's an exercise in there that doesn't really have a mix of all the rearranging equations. They normally focus on one thing. But yeah, I'll see what I can do. And that's it. End of lesson.